Welcome to today's video session on cognitive biases. You will learn how these hidden patterns of thinking shape our decision and interactions, especially in computing. First, you will learn to recognize cognitive biases that distort reasoning. Next, we will explore how these biases impact computer science research. And finally, we will discuss effective strategies to mitigate their influence and improve the quality of our work. A cognitive bias is a consistent pattern of poor judgment in a specific situation. This long list of biases has been shaped by human evolution. Biases have been studied extensively in experiments. We can describe them, but we have to live with them. Some biases are actually adaptive and beneficial. They can lead to more effective actions in certain contexts or enable faster decision-making, which in the past could improve survival and reproductive success. Others arise from flaws in brain structure or from misapplying a mechanism that is useful in one situation but harmful in another one. It's important to be aware of these biases and to actively limit their influence, especially in contexts where accuracy and fairness are critical. Let's look at 3 common cognitive biases that often affect human-computer interaction. First, confirmation bias. This is the tendency to seek out or favor information that supports what you already believed. This might mean a user skimming search results and only clicking links that match their preconceptions and ignoring contrary evidence. For example, if you type the question, "Are dogs better than cats?" into an online search engine, articles that argue in favor of dogs will appear first. If you reverse the question and type, "Are cats better than dogs?" you will get results in support of cats. Next, anchoring bias. This occurs when people rely too heavily on the first piece of information they encounter. For example, if your search engine shows a first result, users may treat it as the result even if better alternatives exist. Finally, the availability heuristic. This is when people judge the likelihood of something based on how easily examples come to mind. In a computing context, if a user recently experienced a security breach, they may overestimate the risk and chance their behavior disproportionately, even if the statistical likelihood is low. These biases can subtly shape decisions, and being aware of them is a first step in designing interfaces that guide users towards more balanced choices. Cognitive biases shape user behavior when interacting with computer systems. Computer systems can trigger these biases, influencing and even steering user behaviors and decision-making. Human-computer interaction research examines the practical effects of these biases and develops tools to measure when and how they occur in interaction. Using that understanding informs the design of computer systems, allowing designers to intentionally leverage certain biases. The goal can be to mitigate harmful biases, for example, counteracting dark patterns that exploit users into clicking on ads they never intended to, or to make beneficial use of them, such as applying nudges to guide behavior. In either case, applying these insights helps address human behavior in real-world contexts. To mitigate cognitive biases in research, several strategies are essential. First is awareness. Designers, developers, and users need to recognize common biases. Incorporate bias awareness training into experiment and software development. Providing balanced and complete information helps counter confirmation bias, while using neutral framing avoids framing effects. You should build systems that encourage fact-checking and expose users to multiple perspectives. Present alternative options or counterexamples to challenge anchoring and availability heuristics. Use nudges thoughtfully to guide users toward well-informed choices without manipulation, and actively avoid or remove dark patterns that exploit biases. Finally, process safeguards. In research, pre-register hypotheses to reduce p-hacking and cherry-picking. For AI systems, ensure diverse training data and conduct bias audits. Provide users with feedback on their decisions and allow undo or review steps to help correct hasty, bias-driven actions. Together, these approaches help create more reliable, fair, and transparent research outcomes. As you have seen, cognitive bias is a natural part of human thinking, but it must be recognized and addressed to ensure sound research. Maintaining objectivity is essential in all scientific work. By understanding cognitive biases, you can design better studies and develop new research approaches that are more reliable and impactful.